We're on. Let's see. Okay, it doesn't look like anyone else is on, so good start. Good start. Can any? No, there's no one out there, so no point asking. Someone is watching at least. If you're watching, just pop your name in the chat box so I know who the hell you are. I know who I'm talking to. That's always a thing. Reason why the camera is moving it up as usual, I'm wearing the damn camera. I mean, it's really annoying to have to sit still. Can you hear me? Got another person there? Is my voice coming through? Someone just pop a message in chat box. That would be incredibly useful. Because the sound thing doesn't appear to be picking up. I'm not sure. Maybe I'll ask him there because he can't hear me. Hello. Yeah, so basically, I'm just worried about the sound as it stands because, like, hey, Katerina, hello. Appears like, yes, you can now see sound. For some reason, sound has gone off. Can everyone who's watching sign in or just say hello? Or brilliant, Sally. Just say hello so I know who I'm talking to. It's always handy to know who you're addressing. And apologies for the camera wiggling around. As usual, I'm wearing it, which I think I said before. We'll start in a minute or two, see if we can pick up any other people. That would be great. It should take about half an hour, and I reckon this is going to be two parts, one today and one, brilliant, and one on Sunday. Just looking at the content, these are the difficult bits of normal. So I've lost about 3 people then. I just said like he's going to be in two parts. I'll come back on Sunday. Who have I got? So I've got Katerina, I've got Sally, and there's somebody hiding in the shadows, or keeps flipping in and out. We'll give it another minute or two. We'll see if anyone else shows up. We had 5 a minute ago. Now we have 2. What I'm going to do is, like, first, say 5 to 10 minutes, I'm just going to recap what we covered last lesson, mainly because we need it. Then I'm going to do binomial to normal. So if I flip through, that's past standard normal. I'm going to have to do the equations of sigma and mu, but the real focus is 3.6 approximate binomial distribution. That's where I'm going with today. And then the last bit, maybe I'll do Sunday. Hello, Oliver. How are you? Interesting. How long? About half an hour, hopefully. I have to go and tutor after this, and then I'm going to go and pray. Anyone who's been watching the coronavirus would definitely recommend praying because it seems to get a bit spicy out there. So yeah, no longer than half an hour, definitely. So what is it? 2 parts. So we'll say I'll start in about a minute or so. Yeah, half an hour. And then whoever comes in, they won't miss that much because the first bit's just recap and me just talking to you about the basic ideas you need for this lesson. So I will start in about a minute or so. We'll just pick up a few more people if we can. It's like some of these guys will have used it for the first time and all this. If you are watching but you haven't got, like, if you haven't logged into the live chat, the way to do it is use your Google Classroom account, and that way you can ask questions. Kind of pointless using a live stream as a video, otherwise I could just make videos. So if you can do that for me, massively helpful. So if that's a possibility for you in any way, also it lets me know who I'm talking to, and that really does matter because you'll get you'll get teaching set for you rather than me just speaking at my computer. All I can see is a computer screen. I know Katerina's out there, I know Eve's out there, I know Oliver's out there, I know Sally's out there. So I'll be teaching for those four because I know you exist. So if you are out there, and it was the case that last time when I looked, there's 5 people on the chat and there's like 16 people watching. Yeah, some of them is random people. Like there's this random Brazilian guy that just watches my video to the hell of it. No clue who he is. It's not Steph. Mad. Anyways, okay, let's get right. I'm bored. You're bored. We're both bored. All right, cool. So I'm going to ask you a few questions just to recap some of the basic ideas. So do you remember the normal distribution? Do you remember, or let's pick a random fact that's worth remembering. Do you remember where the points of inflection are? Type in your answers in the live chat. Do you remember where the points of inflection for normal distribution are? It's got nothing to do with anything. Yeah? Just a quick reminder. Where are the points of inflection on the normal distribution? Where would you find them? Type it into the live chat. So I've got an idea of what we've got here. So points of inflection. I mean, what they are, you should know, is that's just mathematics, isn't it? Knowing that they're f dash of x is 0, and they're the ones where the gradient keeps the same gradient either side of the 0. One standard deviation away from what? You're absolutely right, Eve. I think you know this really, though. One standard deviation away from what? Plus or minus sigma. Well, basically, what they are is the points where you have dy dx equals 0, and immediately left and right of it, you have the same style of gradient: positive, positive, negative, negative. Can you, man, see me? I can see you. I can see you in the text box. I mean, if you suddenly see you in the video, that's some super hacking skills which I haven't got. Please don't steal my video. As for what they are, so as for where they are, you get your mean, add a standard deviation one side, take a standard deviation for the other. Wow. True, but wow. Here's another thing I want to just quickly remind, or just check with you. What's the difference between what the normal distribution does, as in like normal that you can get straight off, and the inverse normal? What do they do that's so different? Why do we have to have these two separate things? Again, pop the answer in the chat box. So what does the inverse normal do that this kind of standard normal, by which I don't mean the Z normal, I just mean the normal distribution that you can do in your calculator, the first option? What's the difference? I didn't bring my calculator with me, so someone's going to have to be calculator slave at some point. So what is the difference between those two? Pop an answer in the chat box if you can. If you're not sure, just say so, because that's kind of also fundamental to a lot of the stuff we're doing. Yeah, so like, which one? So the first one, like just the normal, tells you, okay, let's take an example. Suppose your mean of whatever it is 5, and your standard deviation is 2. What is the probability of getting 7 or more, for example? Yeah. So the normal distribution just tells you, okay, what's the probability of something happening? So you can go, okay, the average person scored 60 in the exam. What is the chance of getting 65 or more? So what probability have you got of 65 or more, for example? Yeah, and I mean, inverse gives you area, but the thing I just want to add to that is that area is probability for this guy. Yeah. So for the normal distribution, the area that you've got is the same as the probability of something happening. And that's maybe something I said, but I didn't really push too much on you. But all the time you're thinking, well, the normal distribution is a probability distribution. The area under the graph totals 1. So think of it, yes, as an area for sure, but also think of it as a probability as well. All right. Anyways, so what are we going to do? Let's just quickly look at, hopefully you've got your notes with you. I'm going to use the textbook. Before we do the main focus of this lesson, which is the idea of binomial to normal, can I just talk to you about finding sigma and mu? Now, I'm looking at the screen and the picture's absolutely diabolical. I don't think you can see real detail on that. So can you flick to 3E, which is page 51 in your pack? And then we'll start talking about that. It says the random variable, and we're going to do number 1. It says the random variable x squiggle n, which just means n is normally distributed, is 11. Sorry, my apologies, that's the wrong one below. It's mu 5 squared. And the probability of 18 is 0.903. Sorry, apologies, that's rubbish. I'll put it here. The probability of x being less than 18 is 0.9032. So the type of question you get here is, we're going to use the standard normal. I mean, my advice to you then is, I'm glad you're here. That's super. But when you get a chance to be at home, obviously then you can do the exercises best there. So maybe just hang around and just see what you can pick up. Just make what you can of it, Katerina. It is what it is, all right? So this is what we're going to be looking at. It's exercise 3E. And here we're being asked to find mu's and sigmas given some information. And you recall the last thing that I taught you really was the standard normal. So you know the standard normal is going to be involved somehow. Yeah? Is that making sense to you so far? So what do we do here? I'm just going to pop this book up. And what they're basically going to say to you is, well, work out what the probability of x equals 18 is normally. Yeah? So what you do, use your calculator to do that. Could someone work that out for me and pop that into the chat box now? So we've got that this is 0.9032. And I'll show you what I want you to calculate. We know also that by the normal, we have got here, we've got 46 minus mu. Well, yep, minus mu, because that's how that works, over sigma, which we know is 5, would equal that. Yeah? Hopefully that makes sense to you so far, right? So all we've done is just work out a calculation on those lines, and we should be able to find out something about mu. Yeah? So if you can solve that one for me, because I haven't got my calculator with you, can you see that comfortably? I mean, I'm sort of kind of looking away at it because I was looking at the book just to getting sure I'm getting the calculation right. So the question is asking you to find mu, and they've told you that something over 80, and I've gone with 46. For what reason have I done that? My apologies. Surely that would be 18. Right? Yeah, because I was looking at one example. I was looking and writing about the other. So that's 18 minus mu. It's my mistake. That's legit my mistake. And who the hell is Mustafa Mohammed? I do not know anyone called Mustafa Mohammed. It should be 18 because I was looking at the example, just to answer your question. But I repeat the question, who the hell is Mustafa Mohammed? As for the rest of you, do we see how that works? So you've got 18 minus mu equals over for 5 equals 0.9032. And that's coming from the normal distribution to standard normal formula, which if you remember correctly goes x minus mu over sigma equals. Yeah? Oh, okay. Hello, Hibbo. That's fine. I mean, I thought you're somebody who doesn't belong in our class. So I was ready to kick you off. But now that's fine. As long as you're here, I'm happy. Okay, so we're all happy with that. Yeah, so I did make a silly mistake. Why is Z 0.9032? Because when you standard normalize it, that's where it would be. The probability is identical, isn't it? Is that making sense? So I'm going to try and show you the book as best as I can. The probability, once you've standardized it, would be the same. Yeah? Oh, my mistake there. My mistake there. You're quite right. Maybe make a bit of a kind of hash of this. Because you can standardize normal that, can't you? Could you do that for me? So, no, I'm not making sense either because I'm looking at one thing, I'm doing the other thing. This is the thing about live streaming. Part of this, I do need your kind of patience on this because it's literally the first time I've done a proper, like, difficult thing on a live stream. So, you know, forgive me on this. Yeah, I'm reading one thing and looking at something else. Right, so we're happy that this is 0.9032. Okay. Once you've got that idea that 0.9032, I agree with you that the Z1 won't quite be the same. Well, actually, no, why wouldn't it be? Can we normalize that and work out what Z would be for 0.2? So the probability is 0.2. So what you'd have to do for that is you'd have to go inverse normal. And what you'd need there is what inverse normal value would give you 0.9032. Okay, let's have a think about that. What do we know about the inverse normal? So the inverse normal thing we need to work out is the area is 0.9032. We know that mu is 0 and sigma is 1. Can you get me the z value for that? And then I plug that there. And that was the mistake I made because I was looking at my previous notes and I've just read the wrong note. And I do apologize for that. It's not as clear as it might be. But hopefully that makes sense now. If we're going to standardize normal this side, Sally's right to complain that I can't just use the 0.9032 that I had from the question. What I need to do is standardize normal this area. And how would I do that? By going to inverse normal, doing 0.9032, mu is 0 and sigma is 1. If anyone's got a calculator, I'd be massively grateful if they could do that for me because I don't have mine with me. Is everyone reasonably confident? Just pop in the chat in the text box why or whether they can use a calculator or not. Has anyone not got a calculator? I mean, like, no one's got a calculator. I'll go and get mine, but that'll give you like 30 seconds of staring at my board. I mean, I kind of need some feedback on this because literally, as I said, I copied out the wrong numbers, and I hope I haven't confused anyone terminally. So pop something in the chat box so I know where we are with this. Do we now understand, first of all, what I miscopied, which was I went straight from this to this being 0.9032. And if I standardize, I have to work out the area as a standardized normal. And I didn't do that. That's the mistake I made. So you got 1.3. I mean, you got one. Is that you agreeing with that? Yeah, 1.3. Brilliant. Yeah, superb. Does that now make sense to you what we did and where my error in copying was? Where I just literally was writing out my line and I didn't do, what thing I didn't do was write out the line that should have gone below it. Because I really want to clarify that. Because I'm teaching this, right? You should not go away with the wrong idea of mathematics. And that is to say that if we've got an area, we need to standardize it just the same. And now we can solve for mu. Yeah? Times it by 5. 18 minus mu is whatever that is. So we can work out what mu is. Does that make sense? Yeah? Should we check that we got the right answer? Because 1.3 times 5 is what? 6.5? Yeah? So that would assume that mu is 11.5. So we're going to check that now. I'm going to check it in I've got the textbook here. I just don't want whatever I do today for me to teach you the wrong thing because I'm getting nervous on a computer. Yeah? So I hope that's making sense. We can solve that relatively easily. Find out what this number is, plug it into there. And I mean, if you can do that for me, we can check this one as well. And then you've really got the big idea here, which is you can find both mu and sigma. All right, so let's try this one out. So if someone could just do the inverse normal on 0.99 for mu equals 0 and sigma equals 1. All right, and we'll see if we can get that one right as well. So again, we're standardizing. We're using the inverse with the standard normal because we're using a standard normal formula. All right. So can I, as I said, can someone do that on a calculator? Next time I will bring my calculator. But someone will have to bail me out in the chat on this. So again, inverse normal on 0.990 and 1. Okay, so here's what we're at. We're doing question 2 in the exercise. All right. This time we're not finding mu, we're finding sigma, but the method is much the same thing. So we've got here 2.326. Yeah, is that making sense? So we can get an idea of what sigma is by doing the division here. Yeah, so you're going to be 9. So it'd be 9 divided by 2.236 would give you sigma. Oh, I'm so sorry about that. Were you both in college? I mean, that's not a bad shout. I mean, it's good. I'm glad you're working in college at the moment. I wish I was, but you know, strikes and all the rest of it. So, okay, let me recap you back. Okay, cool. So maybe it was literally just the internet or my internet. I don't know. That might not have been Candy's fault. So let's just quickly recap. What are we doing? We are question 2 in exercise 3. And I think that's as far, I think 3 is as far as we're going to get with this. This time we're finding sigma, right? So I've written out my standard normal formula, x minus mu equals sigma. This time I know mu, but I don't know sigma. Yeah? And what I've done is, because it's telling me that 0.01 is above 20, I know that 0.99 is below 20. You might want to just take a minute and familiarize yourself with that question. We're doing number 2. And then see whether you agree with my working out. And I think Alex is still with me. and drop me a message again in the chat. I mean, live chat is literally the only way I know what's going on in your life. So if you keep literally talking to me on that, so I know where you are, because I'm someone who needs feedback. I mean, in terms of like understanding whether I should be explaining more or just shut up about it and move on or whatever. What I might do, because you got 2.326. So can I ask you to work out what sigma is? And again, I'm going to do that right now. I'm just going to pull out. I have got a calculator, just not the right one. It's this weird French one that I picked up somewhere. Clear off statistics one variable. So here I'd be doing 9 over 2. If we can do this one, 2.326, and I get something of the region 3.87. Let's see if that's right. Okay. What size we do? Yep, 3.87. That was right. Go me. I'm super clever. So yeah, I mean, hopefully the ghost of that early mistake that I made from miscopying should now be well and truly dead in your heads. X minus mu over sigma is what you do, and then on the other side, just work out whatever the inverse normal of the area would be if it was standardized normal. So what you do here, just the rest of this example, you do 9 over 2.326 to get what sigma is. That's just a straight swap. If you do the working out, that's literally just going to be 9 over 2.326 equals sigma. All right. And then that sigma you get is the right answer. I think we've got this. Well, I think I had it in the first place, but hopefully that made a bit more sense to you. Right. So what I need, like whoever's on, can you drop a message to say either yes, I get it, or no, I don't? And then I can help you directly. So I think Selly's on the right path, and all it was left for you for Selly to do was find out what sigma was. And sigma was whatever 9 divided by 2.326 is. I've just checked the solution and it's right. So Katerina's solid. I think Selly's okay. Eve, where are you? Alex, where are you? I think Alex, you're the first one to get it. So hopefully you're okay. Yeah, you've got it. Yep, it was. Yes, that's right. Beautiful, beautiful. So it looks like, despite my dodgy start, we've actually got some learning done here, and I'm super happy about that. So next thing I'm going to ask you is to do one solo. All right. I'm going to write it out on the board in case you haven't got your pack. So Katerina, don't stress. So the question asks you this time that y, you got y tilde. Remember that's a wiggly line. N, and then you've got mu 40. Yeah. And then PY25 is 0.15. And it's asking you to find mu. So it's like question 1, not like question 2. Yeah? I mean, that's weird. I mean, can people not be creepy like that? I mean, it's weird. Because, like, I see Katerina and I'm talking to Katerina. Yes, Katerina? Whichever. Who is the real Katerina, man? Don't do this. I'm bugging out here, yeah? I'm already having my panic attacks by writing out things on the whiteboard live. Like, don't do this to me. If I had to guess, I mean, who would be weird enough to do that? I'm not happy. I'm really not. I mean, Jesus. Anyways, try the question on the board and we'll try and figure out who's the fake Katerina. We should ask Katerina a thing that only she would know. Like, what do I know? I mean, I don't know anything that's like a secret of Katerina's. I can't even ask that. No, I mean, so am I. I mean, why would you? If you are, desist immediately, right? I mean, I might look back on the live chat later and see who the hell it is. Who would it be though? I mean, it's a good class. Anyways, don't stress out too much, right? I mean, one of you, I'm going to treat you as if you're both Katerina, and then that it'll work for whichever one of you is. Can I ask you guys to try number 3 for me and pop up with an answer? So it's question 3 in exercise 3E, all right? And this is you basically proving that you've understood what I've taught you, all right? Despite the fact, obviously, I mean, I imagine this is not the kindest thing I can say to you right now, but there's literally no way I can tell. It's just 40. Hold on a minute. Yeah, it's just 40. I mean, have you got your? I mean, it's a silly question because you're asking. Have you still got the? Have you got the pack with you? Because it's literally 3 in the pack. And this is why I give you a pack. You see, we've got 8 people, and I've only seen. I mean, also I don't know who are the people that never comment on live chats. Talk to me, guys, seriously, because then I can aim my teachings at you. I know Saul's in there somewhere because he said something. It's 40. I said that, but do trust me. But again, if you can have your pack with you and your calculator and your paper when we're doing this, treat it like a lesson because it is like just a lesson, but shorter. Speaking of but short, we've got about 5 more minutes. So I'll make sure at least 3 is mastered. And then I'll have another go. I'll probably have another go on Sunday on some of the other stuff. And there's only 2 little bits left. Oh no, my connection's gone. Stupid Wi-Fi. Sorry, I think my connection just dropped for a second there. So if you just pop a message once you have a solution for this, and then we can talk it through. So you're looking for mu. You know that y less than 25 is 0.15. So what do you need to do? You need to normalize both sides. Yeah. If you feel like you need help with it, a bit of working out done for you, just pop a message in the box. Okay. Yeah, please. So that's question. Beautiful. Brilliant, Sally. Well done. Well done. Can you guys all try that? Don't just rely on Sally getting it right. So make sure that you have this skill. And I want to do just one more. Okay. I'm going to do just one more. I want to do 5 because it shows you what you have to do if it's a simultaneous equation on these guys. But I'm going to give you about, brilliant. Rounds up. Yep. I'm just going to wait on maybe a minute. Then I'm going to do question 5 with you. We'll do it all together as a group. And then you've seen everything that 3E has to offer. That leaves us with 3.6 and 3.7 to finish the course. Bloody hell, there's a thought. But it's true. 3.6 and 3.7 is literally all we've got left. I mean, what we're going to do for revision is going to be something we need to have a chat about at some point, but probably not now. All right. So let's just look at question 5 in just a moment. Can I just make confirmation from who else is still around? Katerina, you're at work, so you can't do this. Alex and Oliver? Yes? No? Maybe? Saul, if you're still hanging around? Drop me a message to tell me that you've kind of understood this or not. It was question 3 in exercise 3. I mean, I'm going to pop this one off now. I mean, you can see the solution there anyways. But yeah, can you send me a message? Make sure on that live chat, let me know that you've understood 3 because 5 will be quite difficult if you haven't. So you've got X is normally, I'm just prepping the next one. X is normally distributed with mu and sigma squared. So both variables missing for 5. And we know that the probability of X is less than 17 is 0.8159 and X is less than 25. Similarly is 0.9970. I don't know how well you can see that. Maybe I should write it directly underneath instead of P of X is less than 25. Is, 0.9970. So that's the next question we're doing. Alex, you got it. Well done. All right, cool. So what I'm going to do is show you 5. Okay, and then I think that's it. So I said half an hour. We've gone a little bit over, but it's not masses and masses. So hopefully we won't have spoiled your holiday single-handedly. Okay, cool. So you notice that both things are missing this time. Okay, and that lends us to simultaneous equations. So let's have a look at how those simultaneous equations will be shaped. So you get 17 here. We'll do the 17 one first. Minus mu over sigma is whatever the normal distribution, standard normal distribution version of 0.8159, and you've done that a few times now, so I think I can just say that is. So again, you go back to inverse normal, 0.8519 is your area, Yeah, by all means, you listen. It's great that you kind of signed in from work. I'm super grateful. Don't think I'm not. So mu equals 0 and sigma equals 1. So again, doing the inverse normal to find out what this guy equals. Same thing here, a second equation. 25 minus mu over sigma would equal whatever 0.9970 comes up with when you do the inverse normal on mu and sigma. All right. So what you do is get a number there, solve for mu and sigma. All right. So what that's doing is giving you a pair of simultaneous equations for mu and sigma, which you can solve. All right. So I hope that makes some level of sense to you. What I'd need you to do for me is give me those numbers so I can write you out a pair of simultaneous equations. So if you can tell me what the inverse normal on 0.8519 mu and 1, mu equals 0, sigma equals 1, and again, mu equals 0, sigma equals 1 for this guy. All right. And then once we do that, we can set up a pair of linear simultaneous equations, which are actually really easy to solve. The numbers will be awkward, but we can live with that. So it's just what we've always been doing. The 0.8519, mu equals 0, sigma equals 1. What value is that? Okay, cool. So if we go, do you mind if I just pop those straight in there? So kill yourself. 0.8. Oh, damn, that's on in this net forever. I've just threatened suicide online. For now, we'll take it. And I swear to God, next time I'll bring my own damn calculator. And obviously, people hopefully will come in confirming or not confirming. But if that's true, and I'm willing to change this up if it isn't, we can go straight to this guy here. So we've got an equation that goes 70 minus mu equals 0.8998 sigma, and 25 minus mu equals 27478 sigma. And I mean, those equations are incredibly easy. You can literally, I don't know, add them to get, no, you'd subtract them. You'd subtract one from the other. That would cancel the mu's, and you'd get something number equals sigma. Yeah? 8, 9, yep, that's right. That looks exactly the same. So if you add, if you subtract these equations from each other, let's call this guy equation 2 and that guy equation 1. I'd say 2 minus 1. You'd get an equation that would go something on the lines of 8 equals 1 point, whatever, 2.4748 minus 0.8998 sigma. So basically, it'll be that number minus that number sigma. And you should be able to work out sigma. And once you've got sigma, you just subs in to get mu. I mean, finish it for me. Give me solutions for mu and sigma, and I'll tell you if that's worked out for you. And that's literally the end of this video. We seem to have 10 people now. Hello, it's Con. I hope you're having a great day. Goodbye. I mean, I wish you were here doing the teaching, my dude. You do a better job than I did. You look at the beginning, it's a bit of a shambles. But you know what? It's really hard to live stream. Never really realized it. I mean, that's a 35-minute live stream without a script. I mean, it's super, super difficult. I'll write a script next time, I think. But yeah, especially when like things don't go right. Anyways, I hope you're well. I mean, I hope Cambridge is treating you well. Does having think of it? Well, you need to think about which way the probability is, if that makes sense. For here, it just works nicely because they're both the same way, and it's both the way the calculator wants it. Hello, Pia. I mean, it's a long time no see. I will respond to your email. I mean, like, it's literally on my. It should be far, far higher on my to-do list, given how nice your last email was. Cambridge. I mean, if we're teaching partners, you're the senior partner, boss man. I remember your skills. It would be an honor and a pleasure, but we can do better can do better than Candy. I mean, that's on video. Can no one report that I just said that? But like, yeah, it will be an honor. Yeah. So Cambridge is terrible. I mean, I was going to head up your way for a debating thing. If I do, I'll let you know. Who's Alkali? Are you the random Brazilian dude? You're not Armani. I know that because Armani is A-OK, which I thought was quite clever. Actually. Alkali. It's not Alvin. Alvin's some weird dragony thing. Anyways, so yeah. So 8 equals 1.1. Yeah, give me what sigma is, boss man. We'll check that, right? Remind me. Come on, give me a name. Don't be like that. I mean, like, it feels like old friends are coming back just to say, like, hi. I wonder if half my class are here. I mean, not that I'm ungrateful. It's super cool to hear from Khan, Pia, 4 and 13. Okay. Yeah, let me have just a quick check. I think you're right, but yeah, so Sigma's 4.32, mu is 13.1. Beautiful, beautiful. We've learned something. Even with my god awful teaching, you've learned something. I feel super proud of you. Not super proud of me for making a mistake in the beginning of the live stream, but I'm super proud of you. I am now going to shut up. Thank you all, especially the ones who popped up on live chat. And like some of you old guys, I mean, bless you for coming out and you remember how kind of like, I don't know if you've ever live streamed, it's super hard to do it. So it really does help to have positive comments. So thanks for that. Take care of all yourselves. We're gonna have another go on this on Sunday about maybe 5 o'clock, I'm thinking. And it will be the last, and that would finish the normal distribution once and for all. No, it was my pleasure. And thank you for your patience, especially with how nervous I am. I'm gonna get better at this and I'll stop making dumb mistakes. Promise. Thank you, boss. I really appreciate that, Sally. Positivity really does support me, right? So look after yourselves. If you need any help, drop me an email with a picture or something on it with a question. I'm going to start mine in the next 2 days. Pierre, you're like literally like this sunbeam. I mean, thank you. It really means a lot to me. Take care, guys. Look after yourselves. Have a lovely day.